In 3.1 part 2, we're going to be going over another strategy for division, which is called synthetic division. So this one we can only use sometimes. Long division works every time. So by the end of today, you will know when you can use synthetic division and how to do it. So a lot of people like synthetic division because it only uses numbers. It doesn't use the variables, only at the beginning and the end. So it takes a little less space, and sometimes for some people it makes it a little faster. So for synthetic division, this is how we set it up. So we have to check the same way as we did before that we don't have any missing terms. So I have x to the third, x squared, and everything below x to the 1, x to the 0. So I have all my terms from x to the third all the way down. So now what I'm going to do is I'm just going to take the coefficients from those numbers. So this has a coefficient of 1, so we put that here. This has a coefficient of -1, so that goes next. -27 and -28. So using those numbers, I'm going to do similar of what we did with long division, but this time my answer is going to go on the bottom, so I put a little box there, leaving space for another row of numbers right below my first row of numbers. Now over here, again, I'm only going to be using numbers, and so we have to use the matching root for x plus 4. So it's just like if I'm graphing and I'm looking for where is this actually going to cross the x-axis. You set it equal to 0 and solve. But in this case, it'd be pretty quick to see. I just have to minus it to the other side, so it's just going to be the opposite number. So if it's plus 4, I'm going to use -4. If it's -5, I'm going to use +5, so on and so forth. So I put that number over here on the left side, and then I start my division. So that's the process for setting it up. Now here's the process for solving. So the first term on the inside, first coefficient, just comes straight down always. That one never changes. But what happens after this, which is similar to long division, is that we take that number and we multiply it by the number up front. So 1 times -4, and that answer goes here in the next column. Now this part is different. In long division we subtracted, but here we're just going to add these numbers together. So -1 plus -4 gives me -5. And then I do the same thing. Whatever number comes to the bottom, I multiply by the number up front. So -5 times -4, which is +20, and I just put it underneath the next number in the next column. And then I add those two numbers together. So -27 plus 20 gives me -7. And then I multiply -7 times -4, which gives me +28. So when I add these together, I get 0. So this last number down here is my remainder. So this time I don't have a remainder. So these numbers next door, just those three that I found out underneath, those are the coefficients of my new answer. So writing out my answer now, I'm going to be using these coefficients, but then I have to actually be using the right variable. So my original variable was x to the third, but I'm dividing by x. So x to the third divided by x, we're going to go 1 degree lower, so it's going to be x squared. So this first number here, the 1, is my coefficient of the x squared term, so 1x squared, or just x squared. And then this next number is going to be the coefficient of my x. I just go 1 degree lower from there, -7, which is my constant. And then I don't have a remainder, but if I did have a remainder, I would do the same thing with it as I did with long division. So I just put +0 or whatever the remainder is over whatever I'm dividing by. So in this case, it would be x plus 4. But since it's 0 for us, then our answer is just going to be this part right here. So there's synthetic division. So it is a little bit more condensed, just using the numbers, which some people like. But again, it doesn't always work, and we will talk about later when it does not work. But let's do another example. Right here, next example. So if you want to, go ahead and pause the video and try this. but we'll set it up, check for no missing terms. No missing terms, so I just write out my coefficients. And then what number do you think I'm going to use from that? Since it's x minus 3, I'm going to use a positive 3. Okay, next piece. I'm going to start my division. And remember, this first term always just comes straight down to the bottom. We don't do anything with it except bring it straight down. And then we start multiplying 4 times 3, which is 12. That goes in the next column. And then I add those terms together, which gives me negative 4. And then I multiply negative 4 times 3, which is negative 12. Add those terms together, which gives me positive 8. And then we multiply again 8 times 3, which is 24. Add those numbers together, and I get a positive 8. So this time I do have a remainder because that last number is always my remainder. So again, my original, I have to fill in my variables, and originally I started with x to the third, but I'm dividing by x. So x to the third divided by x will go down to x squared. So this first term here is the coefficient of x squared. So 1 degree lower than what I started with because I'm dividing. And then I go down from there. This is the x term. Positive 8 is my constant. And then I have a remainder this time. So it's a positive, so I put a plus 8 at the very end. And then I divide it by my divisor from the original problem, which is x minus 3. So then that right there is my final answer. Okay, next example. Again, if you think you could do this, go ahead and pause it, try it out first, and then check your answer afterwards. This time, I do have missing terms. I'm starting with x to the fourth, and I have an x to the third, but I'm missing my x squared and my x term. So I have to fill those in. So, filling them in, since I don't have them, what number represents nothing? Because I don't have an x squared and I don't have an x. So the number would be 0. So we fill those in with a 0, and then we do the same process as what we just worked on. So then I fill out my 1, negative 9, 0, 0, and negative 1. Make my box. And then again, what number am I going to use from my divisor? Since it's x minus 9, I'm going to use a positive 9. And then I start multiplying, or dividing. The 1 comes straight down. 1 times 9 is 9. Add those together. I get 0, which is a little different. We haven't seen that yet, but it's the same process. So 0 times 9, which is 0. Add those together. 0 times 9 again, which is 0. Add those together. 0 times 9 again, which is 0. Add those together, and I get negative 1. So this is my remainder this time. So looking back at our original expression, we started this time with x to the fourth. So now when I write out my answer and fill in my variables, this 1 right here is going to be the coefficient of x to the third, because it's 1 degree less than what I started with. So this would be the coefficient for x squared, which I don't have, 0x, 0 for my constant, so I don't need to write any of those because I don't have them because of the 0, and then negative 1 is my remainder, so negative 1 divided by my original divisor, which is x minus 9. So there we go. Final answer right there. But it is so important that you fill in those missing terms, because when we start filling in coefficients at the end, we need an x to the third all the way down to x squared, x, constant, and the remainder. We need all of those terms available to us. Just a reminder that synthetic division does not work all the time. It only works for us when we have a coefficient of 1 and an exponent of 1. So this guy right here needs to be just a plain old x. So not a 2x, not a 3x, not an x to the 4th or an x squared. So no coefficient, just needs to be 1, and no exponent, just needs to be 1. So just regular x. But you can have x plus a number or x minus a number. That part doesn't matter, but synthetic division will only work if you have a regular